of the Nobel Committee for Physics to make some remarks. David, please.
Thank you, Göran. On behalf of the Nobel Committee for Physics, I would like to congratulate the laureates in receiving the 2020 Nobel Prize. This year's prize celebrates the discovery of one of the most exotic objects in our universe, the black hole. For many years, physicists questioned the very idea of a black hole, treating it as a peculiarity in our theory of gravity. Roger Penrose showed that black holes might really exist, forming in a stable and robust process consistent with the theory of general relativity. Reinhard Genzel and Andrea Goetz led research teams to make precise observations over many years, which pointed to the existence of a supermassive black hole in the center of our very own galaxy. My colleague in the Nobel Committee for Physics, Professor Ulf Danielsson, will tell us more about the contributions of this year's laureates to the discovery of black holes.
Thank you, David. And now, Ulf, the floor is yours.
As early as the end of the 18th century, the English astronomer John Michell and the French scientist Pierre-Simon Laplace speculated that there might exist objects with a gravity so strong that not even light can escape. We now call such objects black holes. To create them, you would need to compress the sun into a region only a few kilometers across, or to squeeze the Earth down to the size of a pea. But it was only in 1915, when Einstein formulated his general theory of relativity, that we had a mathematical framework powerful enough to describe such objects. Physicists, Einstein himself included, were confused for decades. The mathematics was too complicated. Could something like that actually occur in the universe? And then, in 1905, inspired by the discovery of new violent phenomena in the universe in need of an explanation, Roger Penrose published a remarkable paper. He introduced new mathematical tools and proved with mathematical rigor that the formation of black holes is an inevitable consequence of general relativity. In a universe governed by general relativity, the formation of black holes is a natural and expected process. Let us study now a black hole a little bit more closely. In general relativity, there's an intimate relation between gravity and time. Down at my feet, time runs of a second slower per hour than it does up in my head. And if you have a black hole, time even seems to stand still at the horizon of the black hole. Now, I can point towards the black hole and say, there it is. There is the center of the black hole. My finger is stretched along a direction of space. But if I then bring my finger a little bit closer and let the tip of my finger go through the distance and enter into the interior of the black hole, I will make a startling and somewhat worrying discovery. The direction inwards is, and the tip of my finger will be in my far future. And it will be as difficult to pull my finger back out again as it would be to travel backwards in time. Furthermore, my finger will be torn apart, and the tip of my finger will be carried by time all the way into the center of the black hole, where time itself ends, and the known laws of physics cease to apply. But if such objects now actually exist in the universe, then how could you find them? Well, actually, already in 1783, John Mitchell had an idea. What if there are other luminous objects, such as stars, moving around the black hole? Then one could infer the existence of the black hole by following the motions of the stars. But it would take more than 200 years before this dream would come true. And it was Reinhard Genzel, Andrea Ghez, and their teams who did it. They turned their telescopes towards the center of our galaxy, 26,000 light years away, where there were suspicions that something strange was going on. The heart of our galaxy, the heart of the Milky Way, is hidden inside of a dense cloud of dust. And you have to look in the infrared to reveal its secrets. What they found was incredible. They could see several stars moving around something that they couldn't see. And it was one star in particular that caught their attention. It took the star around 16 years to complete its orbit. At closest approach, it was no more than 17 light hours away from the invisible object. Calculations show that 4 million solar masses is hiding there. There is no other explanation than a supermassive black hole. This year's laureates have uncovered secrets in the darkest corner of our universe. But this is not just an old adventure coming to its triumphant conclusion.